Hello, good afternoon. A very warm welcome to all of you. Good afternoon, good afternoon, good afternoon. How are you all doing? Good afternoon. Is the audio and video fine, loud and clear? Everyone? Yes? Nice. Okay. So, welcome to the first session of Super 20 for GATE 2026. This is going to be the Super 20 series where we are going to solve the best 20 questions of every subject for mechanical as well as civil engineering, and in this particular session we are going to solve the problems of strength of materials. Now this session is for all the students preparing for GATE mechanical, GATE civil as well as GATE XC. So I welcome all of you once again. Are you guys ready to solve the top 20 questions of strength of material? Let me tell you, I have hand picked these questions for different chapters, for different topics, so that almost all of your chapters and topics will be revised. Good afternoon, good afternoon, good afternoon. And let me tell you one thing, even if you're not able to solve any question, please don't get demotivated. Okay, I've seen a lot of students after solving 2-3 questions, if they're not getting the correct answer, they get demotivated and they stop this session. Don't do that. See, even if you're not able to solve the question correctly in the first attempt, you will get to know the solution, you will get to know some concepts, and that might help you in the exam. Even if you get one correct question right in GATE because of this session, it is worth it, right? It is worth your time. Chalo. So this is my Telegram group. You will get the PDF solution of you will get the PDF of this session after the class uploaded in this group. So join this group. And this is the schedule of Maha Revision, Maha Abhyas and Super 20 for mechanical engineering. So yesterday we completed the Maha revision of strength of materials. If you have not seen that, please go and watch after this session. Tomorrow at 4 p.m. you will have Maha revision of manufacturing process by Swadesh sir. So don't forget to join this live. Okay. And then today at 7 p.m. we have Maha Abhyas of strength of material. Means we are going to solve 20 questions in this session. And after that at 7 p.m. we will meet at GATE Wallah mechanical channel, where we will solve another 30 questions of strength of material. Okay. Chalo. And this is the Super 20 series which will take place on this channel. This is the schedule for mechanical, and this is the schedule of Maha revision for civil engineering tomorrow at 4:30 p.m. All the civil engineering students, you have Maha revision of Geotech by Badal sir. So don't forget to watch this live. Okay. Tomorrow 4:30 p.m. GATE mechanical channel. This is the schedule of Maha Abhyas for civil engineering. Okay, so 7 p.m. you also are invited for Maha Abhyas of strength of material, and this is Super 20. Okay, chalo. So this is the syllabus of strength of material. I have selected the questions from each and every chapter. Depending upon the weightage, you have more or less questions from different chapters. Okay, so without any delay, let's start with the first question. Are you guys ready? Please write in the comment section. Are you guys ready? Shall we start? Yes. Okay. So we'll start with the first question from the topic of thermal stress. A 3-meter long copper bar with a cross-sectional area of 350 mm square is placed between two rigid walls. At a temperature of minus 20 degrees centigrade, there is a gap of 2 mm as shown in figure. Young's modulus is 100 gigapascal and coefficient of thermal expansion is 18 into 10 to the power minus 6 per degree centigrade. Find the temperature at which the compressive stress in the bar will be 40 megapascal. So this is related to thermal stresses, but in this particular question, I'm not asking you to calculate the thermal stress. I'm asking you to find the temperature at which the thermal stress will be 40 megapascal. How do you solve this question? Anyone in the comments? What is to be done here? Okay, so we are getting answers already. Very good, very good, very good. Okay, so this is based on compatibility equation, right? What will be the compatibility equation? Total change in length will be equal to the gap, right? And this will be change in length due to temperature plus change in length due to force should be equal to the gap. What will be change in length due to temperature? L alpha delta T. And what will be change in length due to force? PL by AE, or you can write sigma L by E. Instead of P by A, you can write sigma L by E. And sigma will be compressive. So I have put negative sign here. Okay. This will be equal to the gap. Now put all the values here. What is the length? 3 meters. So 3000 mm. Alpha is 18 into 10 to the power minus 6. You need to calculate delta, right? Sigma is 40 megapascal compressive. So negative sign is already here. Young's modulus is 100 gigapascal. And the gap is how much? Gap is 2 mm. So from this equation, delta T is how much? What is delta T here? 2 plus 40 into 3 into 10, 3 divided by 100. Okay. Answer divided by 300,000 into 18 into 10 to the power minus 6. I am getting 59.26 degrees centigrade. Almost 60 degrees centigrade, right? But will that be the answer? 60 degrees centigrade is here in the options. Will that be the answer? No. They are asking you to find the temperature at which the stress will be 40 megapascal. So delta T means final temperature minus initial temperature, right? This is almost 60 degrees centigrade. Now this will be 60 plus initial temperature. And initial temperature is minus 20. So final temperature will be 40 degrees centigrade. So the correct answer is 40 degrees centigrade, right? C is the correct answer. Very good everyone, very good, very good, very good. So this was the question based on the concept of thermal stress, but you need to carefully understand the question, you need to carefully read the question, because a lot of students might make the mistake of writing this as the correct answer, 60 degrees centigrade, right? But 60 degrees centigrade is the change in temperature. Final temperature will be 40 degrees from minus 20 to 40. So this was our first question. Shall we move to the second question? Are you guys ready? Chalo. So this is the second question. The state of stress at a point is shown in figure. If the element is rotated 60 degree clockwise, the shear stress on the new element will be. State of stress is shown in the figure. Element is rotated 60 degree clockwise. You need to find the shear stress on the new element. So this is the question related to stresses on oblique planes, right? You already know the formula of stress on oblique plane, tau at angle theta. But here they are asking you to find the tau on a plane which will be rotated by 60 degrees centigrade clockwise. So right now this is the element, okay? This is the vertical plane, this is the horizontal plane. If I rotate it by 60 degree clockwise, I am going to get this, right? I have rotated it by 60° clockwise. So this is your vertical plane. Initially this was your vertical plane and now this is your new plane. Okay, so I have rotated it by 60° clockwise and now I want you to find the stress on this plane. Okay, what will be the tau on this plane? So tau at angle theta will be minus of sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta, right? So what is sigma x? 150, sigma y 100, tau xy 75, all are positive according to our sign convention, right? And what will be theta? So theta will be 60° clockwise, and clockwise angles are always taken as negative. So we will take theta as minus 60°. Okay. What is sigma x? 150, sigma y 100. Okay. Theta will be minus 60, so this will be minus 120°. Tau xy will be 75 minus of 120°. Okay, so what is the shear stress? What is the shear stress? 150 minus 100 will be 50 by 2, 25. So 25 sine minus 120 plus 75 cos minus 120, and the answer is minus 15.85 megapascal. But they are asking you to find the magnitude of shear stress, so you will put 15.85. Okay, it is not mentioned what sign has to be put, so you will put only the magnitude 15.85. Unless the sign convention is mentioned, you don't need to put the value with sign. Okay, just put the magnitude 15.85 megapascal. Okay, very good. Let's move on to the second question. Chalo. A titanium bar, Young's modulus 100 gigapascal and Poisson's ratio 0.33 with square section of side 75 mm and length 3 meters is subjected to a tensile load of 900 kilonewton. Increase in volume of the bar is approximately. The diagram is not given, but have been given. Know how the force is acting, right? Okay. So this is titanium bar subjected to a tensile load of 900 kilonewton. You need to find the increase in volume or change in volume. You can directly use the formula of volumetric strain, right? What is the formula of volumetric strain? Epsilon V. It is 1 minus 2 nu by E sigma x plus sigma y plus sigma z, which will be equal to change in volume divided by original volume, right? Epsilon V means change in volume by original volume. So here all the things are given in the question, but you need to calculate the stress first. Now the bar is subjected to uniaxial load, right? There will be only one sigma, okay? Sigma x, which will be force divided by area. What is the force? It is 900 kilonewton. So 900 into 10 to the power 3 Newton. What will be the cross sectional area? 75 into 75. The square section. So you will get sigma x, sigma y and sigma z will be 0. So sigma x is 160 megapascal. Now put that in the equation of volumetric strain. So change in volume divided by original volume. Now original volume will be length into width into height. Okay. 1 minus 2 nu by E. Nu is 0.33 and E is 100 gigapascal. So 100 into 10 to the power 3 megapascal. This is 160. Sigma y is 0. Sigma z is 0. So from here we will get the change in volume. So how much is the change in volume? 1 minus 2 into 0.33 into 160 into 3 into 10 to the power 3 into 75 square divided by 100 into 10 to the power 3. So it is 9180 mm cube. This is the change in volume of the bar. 9180, almost 9200 mm cube. Yes. So D is the correct answer. Very good. Excellent, everyone. D is the correct answer. Clear, everyone? Okay. Let's move on to the next question. A horizontal load F is applied at point R on a two-member truss as shown in figure. Both the members are prismatic with cross-sectional area A0 and made of same material with Young's modulus E. Horizontal displacement of point R is. Let's see. Okay. So horizontal force is acting at the joint, right? Now this is a problem related to Castigliano's theorem. This is a truss which has two members PR and QR. Okay. And a horizontal force is acting at R. We need to find the horizontal displacement. Means we don't need to consider the dummy force here, right? We don't need to consider the dummy force. So what we will do, we will calculate the total strain energy and we will differentiate that total strain energy with respect to F. Okay. But in order to do that, we need the force acting in PR and QR. So by method of joints, we can find the force acting in the member PR and QR. So this is F PR, this is F QR and this is F. This angle is 45 degree and this angle is also 45 degree. So from summation of Fy equal to 0, what you are going to get? FPR will be equal to minus of FQR, means both forces must be equal and opposite. Now from summation of Fx equals to 0, FQR plus F minus FPR equal to 0. So FQR plus F plus FQR equal to 0. So FQR will be equal to minus F by 2 and FPR will be equal to plus F by 2, right? Both forces will be equal and opposite. They will be F by 2, F by 2, right? Oh, so sorry. I made a mistake here. It will be FQR cos 45 plus F minus FPR cos 45 equal to 0. So this will become 2FQR cos 45 because this will become FQR equal to minus F. So FQR will be equal to 1 by 2 cos 45 means 1 by root 2, na? So minus F by root 2 and FPR will be equal to plus F by root 2, right? So both are equal and opposite, F by root 2, F by root 2. Now we need to find the strain energy. So total strain energy will be strain energy in PR plus strain energy in QR. And what will be the strain energy due to axial load? P square L by 2AE, right? So P square L by 2AE in PR plus P square L by 2AE in QR. Now both have identical forces, both are subjected to equal forces, only the sign is different, na? Both have equal length, area and Young's modulus. So can I write it 2 times of P square L by 2AE of PR? Yes, because everything is equal, na? So P square will be equal to F by root 2 square. So this will become F by root 2 square. What is the length? So this is L. So what will be this? This will be root 2L, na? Length will be root 2L divided by 2A0E. So what will be the strain energy here? This will become 2, na? So this 2 and this 2 will be cancelled. So it will become F square L by root 2 A0E. This is the total strain energy, right? Now horizontal displacement of R according to Castigliano's theorem will be equal to del U by del F, right? So del by del F of F square L by root 2 A0E. If you differentiate F square with respect to F, you will get 2F and 2 root 2. So XR will become root 2 F square L by A0E. Sorry, root 2 FL by A0E. So what is the correct answer? D is the correct answer. Yes. Root 2 FL by A0E. Ronak, very good, excellent. Very good, excellent. So the correct answer is root 2 FL by A0E. Clear everyone? So first you calculate the force in each member, then you calculate the total strain energy, then differentiate that total strain energy with respect to F in order to get the horizontal displacement of joint R. Okay. So you can see that we have variety of question. First the question from thermal stress, then the question from complex stress, then the question from Castigliano's theorem. So from different chapters, from different topics, I have gathered the best 20 possible questions. Okay, I hope you guys are enjoying the session. And let's move on to the next question, again from axially loaded members, because axially loaded members is one of the most important topic, most important chapter. The homogeneous bar with a cross-sectional area of 600 mm square is attached to rigid supports. The bar carries axial load of P1 equal to 20 kN and P2 equal to 60 kN. the magnitude of normal stress in the segment BC is. We need to find the stress in BC. So how do you find the stress in BC? In order to find stress in BC, you will need to first find the what? You will need to first find the reaction forces, right? Either at A or at D. Any one reaction force you need to find. Can I do this lecture without attending Maha revision session? Beta, Maha revision session is for revision. So if you have already revised, if you remember all the concepts, formulae, to attend this session, no issue. See, my point is, don't try to attend the practice sessions without revising the formulae and concepts. Okay. So if your revision is done, you can watch this session. Okay. So let's draw the free body diagram first. So 0.6, 1.2 and 0.9. 0.6, 1.2, 0.9. Okay. There is a force 20 kilonewton here, then 60 kilonewton here. Let's say the reaction forces are like this. Okay. Let's find out the reaction here, RA. We need any one reaction, A, B, C and D. What is the length? 0.6 meter, 1.2 meters and 0.9 meters. So what will be your compatibility equation? Change in length from A to D must be 0. Means change in length from AB plus change in length between BC plus change in length of CD equal to 0. So change in length of AB will be PL by AE of AB. What will be the internal force in AB? The internal force in AB from left side will be RA. Take a section here. From left, the internal force is RA. Length is 0.6. Area and Young's modulus is common. Then if I take a section in BC from left side, internal force will be RA minus 20 kilonewton. Right? Length is 1.2. Area and Young's modulus is same. Then in CD, it will be RA minus 20 minus 60 means RA minus 80. Length is 0.9 divided by AE equal to 0. Okay. So AE is cancelled, right? If I divide this entire equation by, let's not divide it. This will be 0.6 RA plus 1.2 RA minus 24. Then plus 0.9 RA minus 80 into 0.9 is 72 equal to 0. So 0.6 plus 1.2 plus 0.9. How much is it? 2.7 RA will be equal to 24 plus 72, 96. So RA will be 96 by 2.7, which is 35.55 kilonewton. So this is the reaction at A, 35.55 kilonewton. Yes. Now we need to find stress in part BC. So it will be internal force in BC divided by area. And what is the internal force in BC? RA minus 20. So 35.55 minus 20 into 10 to the power 3 divided by area. What is the area? 600 mm square. So from here I will get the stress in BC. So 15.55 into 10 to the power 3 divided by 600, 25.92 megapascal, and the stress is going to be tensile, right? 25 point something. Very good. Adarsh, Abhay, Anubhav, Rohan, very good, very good. 25.92. Very good, Ronak, Swagatam, very good, very good. Okay. So this is the stress in part BC. You can find stress in AB, you can find stress in CD also, right? Chalo. So this was the question from statically indeterminate bars. Okay. Let's move on to the next question. The maximum principal stress for the state of stress shown in figure is. Is it really possible to crack GATE even with full-time job? Please reply this. You are my favorite teacher. Thank you so much for the appreciation. And let me tell you, see, if you have a full-time job, it depends how much time you are getting after your job, after your schedule, how much time you are getting for preparation. Okay, and what is your what how much you already know. So it all boils down to yourself. See, if you are not able to give more time per day, if you have less time, you can what you can do is you can prepare for 2 years instead of trying to prepare for 1 year. You prepare for 2 years, you prepare your schedule for 2 years. Okay, take it slowly. Okay, just dedicate 2 to 3 hours of time every day. On weekends you can make 5 to 6 hours, and maybe in 2 years your preparation will be completed, and then you can attempt GATE. Okay, but if you are able to dedicate more time, or if that much time is enough for you, then you can also prepare in 1 year. So it all depends on you. For last month revision, Super 20 and Maha Abhyas questions are enough for perfect revision of concepts through question, as full revision of concepts is already done. Yes, see, the objective of this Super 20 and Maha Abhyas series is to revise. Okay, ultimately through these questions we are revising the concepts only. Okay, chalo. So here we need to find maximum principal stress, means we need to find all the three principal stresses. This is the triaxial loading. We need to find all the three principal stresses. But here if you look at this second plane, each row is the state of stress of one plane, right? On this row, on this plane, you only have sigma, you don't have tau. So this is a principal plane, right? And this stress is already a principal stress. So one of the principal stress is known, which is 60 megapascal. And if you remove this, then you will get this 2 by 2 matrix, right? What will be the 2 by 2 matrix? 150, 40, 40 and minus 50. So from here, we can find the other two principal stresses. So sigma 1, 2 will be sigma x plus sigma y by 2 plus minus root over sigma x minus sigma y by 2 whole square plus tau xy square. Okay, so this is already a principal plane. This second plane is already a principal plane, because this tau and this tau is 0, you only have one sigma. And if this is a principal stress, then you need to find only other two principal stresses. So just remove this and you get this. From here you can directly apply the formula. So sigma x 150, sigma y minus 50. And tau xy is 40. So from here you will get the other two principal stresses, sigma 1 and sigma 2. So 150 minus 50 means 100. So this will be 50 plus root over 150 plus 50 means 200. So 100 square plus 40 square. So 157.70 megapascal will be sigma 1, and what will be sigma 2? Minus 57.70 megapascal. Okay. So these are the other two principal stresses. Sigma 3 is 60 megapascal. Okay. So sigma maximum will be equal to sigma 1, means 157.70 megapascal. Yes. Very good, excellent everyone, very good. 157.7 megapascal will be the principal stress, maximum principal stress. Let me tell you, in GATE there has been one similar question, okay, although they were asking something else, but similar matrix was given where one plane was already a principal plane. So if you get a question from triaxial state of stress, it will be probably something like this, where one plane will be already a principal plane. For example, if the third plane is principal plane, then you remove this and you solve the other 2 by 2 matrix. Okay, here the second plane was principal plane, so I removed this, okay, and I solved the remaining 2 by 2 matrix. So this is already a principal stress. The other two principal stresses are this and this. Sigma maximum will be maximum of sigma 1, sigma 2 and sigma 3. So sigma maximum is 157.7 megapascal. Okay, someone is asking if one of the plane is not a principal, then what we will do? Then you will have to find the eigen values, but it will be very difficult. It will be a very long solution. So probably you will never get a question like that. Okay, they also know that you have very limited time to solve one question. So they will not give you a question where the solution is 2-3 pages long. Okay. Chalo. Solve this question. This is from bending stresses. I wanted to thank you from your SOM video lectures. I learned the fundamentals, and from that I cracked the interview. I have this. Thank you so much for the appreciation, and I'm really happy for you. All the best for your future. Do well in your job. An overhanging beam is subjected to a loading as shown in figure. Magnitude of maximum tensile stress in the cross section of the beam is. So here you have an overhanging beam. Okay. You need to find the magnitude of maximum tensile stress. So what you need to do, you need to find the maximum bending moment. Okay. So the beam is subjected to symmetric loading, right? So it will be easy for us to find the reaction forces because they will be equal. 0.5, 0.5, 1, 1. Okay. Something like this. So 10 kilonewton, 20 kilonewton, 10 kilonewton. It's a symmetric loading. So the reactions will be total load by 2. So 40 by 2. This will be 20 kilonewton. This will be 20 kilonewton. Right? Let's say this is A, this is B, this is C, this is D, this is E. So here, if I draw the shear force diagram, the points where the shear force is changing time will be the points where bending moment will be maximum. Yes. So we need to find where the shear forces are changing sign. There can be more than one points. Okay. So first the shear force will start from 0, it will go to minus 10. Then from here to here it will remain constant. Then minus 10 plus 20, it will go to plus 10. Then it will remain constant. Then again minus 20, so it will go to minus 10 again. Then constant. then minus 10 plus 20, again plus 10, then constant, then plus 10 and minus 10, again 0. So 0, 0, minus 10, plus 10, minus 10, plus 10, 0. So see how many times shear force is changing sign. How many times it is changing sign? 1, 2, 3. Here and here bending moment will be equal because it's a symmetric beam. So here and here the bending moment will be equal. So we need to check bending moment at B and bending moment at C. So bending moment at B will be equal to how much? This distance is how much? 0.5, na? 0.5, 1, 1, 0.5. So 10 minus 10 into 0.5, it's a minus 5 kilonewton meter bending moment. And what will be the bending moment at C? Minus 10 into 1.5 plus 20 into 1. So this will be minus 15 plus 20 plus 5 kilonewton meter. So you are getting equal sagging and hogging bending moment, right? You are getting equal sagging and hogging bending moment, but they are asking you to find maximum tensile stress. Now understand this. The cross section is this. This is the cross section of the beam. Now understand a very important concept here. Maybe in this particular question you might not need that concept, but maybe in some other question you will require that concept. This is your neutral axis, right, which is passing through the centroid. Now understand, they are asking you to find the maximum tensile stress. Yes, if you consider this bending moment, which is the hogging bending moment, then you will get the tensile stress at the top. And if you get this bending moment, which is the sagging bending moment, you will get the tensile stress at the bottom. Now why it is important? It is important because it's a triangular section. So the distance of neutral axis from top and from bottom are different. But the good thing is, here we have equal magnitude of both bending moments, so we don't need to check, right? Obviously you have to put your bending moment equal to 5 kilonewton meter because both are equal in magnitude. But in some other question, if you get different magnitudes of positive and negative bending moment, you will have to calculate maximum tensile stress using both the bending moments, and then you will choose the maximum one. Are you getting my point? Here we don't need to do that because the value is same for both. So maximum tensile stress, na, M into Y by I. So maximum bending moment 5 kilonewton meter, maximum distance from neutral axis. See, in this case you will get maximum tensile stress. Sorry, in this case you will get maximum tensile stress because it will be at the top. Okay, and what will be the distance? 300 mm. So this will be 200 mm. This Y will be 200 mm, right? So Y is 200 and what will be I? 100 BH cube by 36, na? So 100 into 300 cube by 36. So what is sigma maximum? 5 into 10 to the power 6 into 200 into 36 divided by 100 into 300 cube. So 13.33 megapascal. Okay, and you will get this maximum tensile stress for this bending moment, sagging bending moment. If you have hogging bending moment, then the tensile stress will be maximum at the bottom and it will be less than 13.33 megapascal. Okay, so it is important to read the question carefully. They are asking you to find the maximum tensile stress, not at a particular section. If they say that find the maximum tensile stress at the center of the beam, then the answer will be different. Okay, chalo. A circular tapered bar of minimum diameter 25 mm and maximum diameter 50 mm is fixed at both ends. Young's modulus is 100 gigapascal and coefficient of thermal expansion is 10 to the power minus 5 per degree centigrade. If the temperature is increased by 60 degrees centigrade, maximum normal stress in the bar is. See, till now in GATE, I don't remember there has ever been a question of thermal stress in tapered bar. Okay, so most probably you might get to see a similar question in GATE. Okay, they might give you a question similar to this. So what you will do in this question, you will use compatibility equation, right? Change in length should be 0 and this should be change in length due to temperature plus change in length due to force. Now due to temperature it will be L alpha delta T and it will be positive because we are increasing the temperature, and due to force it will be compressive and the formula will be 4PL by pi d1 d2 E, right? Now what is the length? Length will be cancelled, so it doesn't matter. Okay, it will become like this: L alpha delta T equals to 4P divided by pi d1 d2 E. So what is alpha? Alpha is 10 to the power minus 5, delta T is 60, P is unknown. What is the minimum diameter? 25, maximum diameter 50. Young's modulus, so Young's modulus is 100 gigapascal, so 100 into 10 to the power 3. So what will be the value of P? $1875. P will be 18750 pi, na? 18750 pi Newton. I am writing it in terms of pi because we need sigma maximum. Sigma maximum will be P by minimum area. So the whole bar will be subjected to the same force, but the area is different. So where will you get sigma maximum? Where the area is minimum. So this pi and this pi will be cancelled. That's why I took P in terms of pi. So 18750 into 4 divided by 25 square, I am getting 120 megapascal. So this is going to be the maximum stress in the cross section, 120 megapascal. Okay, and it will be developed here where the area is minimum. Here the stress will be minimum because area is maximum. Okay, so 120 megapascal. Very good, excellent everyone, very good. Who's getting 60 megapascal? Chalo. A flat steel bar 25 mm wide by 6 mm thick and 1 meter long is bent by couples applied at the ends so that the midpoint deflection is 20 mm. Let me show you the diagram so that there is no confusion. Okay, let's say this is the diagram. Okay, so you have a steel bar which is bent by applying couples at the ends. and the midpoint deflection is 20 mm. You need to find the maximum bending stress. Let me tell you, we got a similar question like this, I think in engineering services or GATE, but it was not in mechanical. I think it was in civil, because I have seen similar question. Now some of you might not know the concept of this, so I will just explain the concept behind this. Okay, watch this carefully. Let's say this is the bar and it was bent. Okay, so if you bend it like this is going to be the elastic curve, something like this, and it will be circular, na? It will be circular, right? Now you have the central deflection, midpoint deflection, this. Let's say this is delta. Okay, now understand, this curve is circular, right? This curve is circular. So if you complete this curve, let's say you get a center somewhere here. Okay, this curve you are getting, elastic curve, it is circular. That is our assumption, right? The elastic curve is circular in case of pure bending. So here if it is a circular curve, let's say the center of that circle is this. What will be this? This is going to be the radius of curvature R. Yes or no? It is going to be the radius of curvature. Now, what will be this? This will also be the radius of curvature. This is the radius, so this is also radius. So if this is delta, then this remaining length will be R minus delta. Yes or no? And what will be this length? What will be this length from here to here? Can I say it is half of the length of the beam, L by 2? I think this diagram is clear to everyone. This point is the center of this circle. Okay, if I complete this circular arc, then this point is the center of that circle. Okay, so this and this both are equal to R. So if this is R, this will be R minus delta and this is L by 2. Now look at this triangle. In this triangle, can you apply Pythagoras and find a relation between R, L and delta? We need radius of curvature basically so that we can find the bending stress. We need R. So can we find R using this equation? Yes, we can. So this R square will be equal to R minus delta square plus L by 2 square. So R square will be equal to R square plus delta square plus minus 2R delta plus L square by 4. This R square will be cancelled, right? Delta square will be negligibly small. Okay, because compared to R and L, delta is a very small quantity. And if you square that, delta square will become negligibly small. So let's neglect this. So R square cancelled, delta square is neglected. So from here, the equation of R will be equal to L square by 8 delta. Now you can use this as a direct formula. You can use this as a direct formula to get the radius of curvature in this particular question. So R will be L square by 8 delta. You have length of the beam. What is the length of the beam? 1 meter, so 1000 mm. And you have delta, which is 20 mm. So from here, R will be equal to how much? 1000 square divided by 160, 6250 mm. What is this? This is the radius of curvature. Once you get the radius of curvature, you can find sigma, right? From this equation, sigma maximum by y maximum equal to E by R. Sigma by y equal to m by I equal to E by R. From there, you can find sigma maximum, right? E will be how much? E is 200 gigapascal. Okay, it's 25 mm wide and 6 mm thick. So height of the cross section is 6 mm. So y maximum will be 3 mm. So 200 into 10 to the power 3, y maximum is 3, r is 6250. So from here we will get sigma maximum. How much is sigma maximum? 96 megapascal. Yes, very good. 96 megapascal will be the maximum bending stress. Okay, I hope it's clear to everyone. Those of you who have not seen this concept before, you can memorize this formula if you want, or you just need to understand this diagram. So you can find this relation anytime, right? I hope it is clear to everyone, because this was a previous year question, okay? In some exam, GATE or engineering services, I don't remember clearly, but this has been asked before, okay? Solve this question. A rod is made from two segments. AB is steel and BC is brass. It is fixed at its ends and it is subjected to a torque of 680 Newton meter. So a question from torsion finally. If the steel portion has a diameter of 30 mm, determine the required diameter of the brass portion so that the reactions at the walls will be same. Modulus of rigidity of steel is twice that of brass. Modulus of rigidity is twice that of brass. So how will you solve this question? They are asking you that you need to keep the reactions same, right? Reactions at the walls should be same. So what should be the diameter of the brass portion? Okay, means the diameter of BC, diameter of AB is given 30 mm, diameter of BC is unknown. So the question looks like this: 1.6 meter and 0.75 meter. It's an interesting question. It is subjected to a torque of 680 Newton meter here at the junction. Due to that, there will be some reactions at the walls, right? And they are asking you to keep the reactions same at both the walls. So if this is T, this has to be T, right? So from here, this net moment must be 0. So it means 2T should be equal to 680. So T should be equal to 340 Newton meter, right? This T should be equal to 340 Newton meter. Okay. Now, we need to keep the, we need to find the diameter of the steel portion. Okay. So how we will do that? What should be the logic here? Okay, theta total must be 0, right? So from there we will get the answer. Yes, theta total must be 0. So theta AB plus theta BC must be 0, or theta AB should be equal to minus of theta BC, or the magnitude of AB and BC must be equal. Na? That should be the logic. Okay, so the torque should be equal in both cases. Acha, we don't even need to do this. Now understand, here T is equal, okay, length of AB portion is how much? Length of AB is 0.75. Okay, G of steel is twice of brass. So let's say G of brass is G, means G of BC is G. So G of AB will be 2G. Okay, this will be pi by 32 d to the power 4. AB has a diameter of 30 mm. So 30 to the power 4. This will be equal to, T will be cancelled. Length is how much? Length of this part is 1.6. Okay, this will be G. This will be pi by 32 d to the power 4. So from here you will get the answer D. So 1.6 into 2 into 30 to the power 4 divided by 0.75. 43.11 mm. Diameter should be 43.11 mm. Yes, are you getting this? 43.11 mm. Very good, Shivam. Very good, Rohan. 43.11 mm. Very good, Anubhav. 43.11 mm. So we don't even need to do this. Okay. See, the torque, internal torque in AB and BC will be equal and opposite, right? So T and minus T will be cancelled. Okay. If the internal torque here is T, internal torque here BC will be minus C. So this entire thing will be cancelled. So 𝐿𝐺𝐽. Okay. So the diameter here is unknown. Rest of the things are given. So we got the answer 43.11 mm. I hope you liked this question because it was a very interesting question, right? It was not a straightforward question. It was an interesting question. Chalo. Let's move on to the next question. A solid rod of diameter 50 mm is hinged at both the ends. Length of the rod is 2.4 meter. Young's modulus is 200 gigapascal and coefficient of thermal expansion is 10 into 10 to the power minus 6 per degree centigrade. Temperature increase that will cause the rod to buckle. A very important question, and this was also asked in GATE before. Temperature at which the rod will buckle. How many questions have we solved so far? One is counting. We have total of 20 questions. I want to know how many questions. Achha, 10 down, including this or before this? Achha, this is the 11th question. Okay, so we are running at the correct time. We are running at a correct pace, right? 1 hour for 10 questions. Good enough pace. Not for you only. Okay, if you are solving on your own in a test series, then it is very less. But we are all solving it together. So obviously, it will take more time, na? Hello. So how do you solve this question? See, when you increase the temperature, thermal stresses will be developed, forces will be developed. Because of the elongation, forces will be developed, right? So the rod will buckle when P will become equal to P critical. What will be P? P will be AE alpha delta T. Thermal stress is E alpha delta T, and thermal force, you can call it thermal force, it will be A into E alpha delta T. Area into sigma means A into E alpha delta T. What will be P critical? Pi square EI by LE square. Now here both the ends are hinged, so effective length will be equal to L. So here you put all the values, E and E will be cancelled. What will be the area? It's a circular cross section, so diameter will be, diameter is 50 mm, pi by 4 50 square. E is cancelled, alpha is 10 into 10 to the power minus 6. We need to find the temperature increase, means we need to find delta T. Pi square, I will be pi by 64 d to the power 4. LE will be equal to the length L, which is 2.4 meter, means 2400 mm. So in this entire equation there is only one unknown, that is delta T. So how much is delta T? Pi square into 50 to the power 4 into 4 divided by 64 into 2400 square into 50 square to 10 into 10 to the power minus 6. So delta is 26.77 degrees. Are you getting the same answer? Very good Shivam, very good Harsh, very good Rohan, very good Swagatam, very good here, very good, excellent, very good Anubhav. 26.77 degrees centigrade means when the temperature change will be equal to this much or more than this, the rod will buckle, right? Chalo. Let's move on to the next question, and this is from shear force and bending moment. A uniformly distributed load of 1500 Newton per meter is applied on a simply supported beam LMN with an overhang of 0.5 meter. Which one of the following statements is false? Now, whenever you have a question like this, be very careful. They are asking you to find which of the statements is false. That is why they are highlighting this word. See, this is written in all caps, because in most of the questions like this, people make the mistake of finding the true statement. They are asking you to find the false statement. Okay. So whenever you have such type of question, double check your answer always. We need to find the statement which is false, and this is an MCQ. It is not MSQ. There is only one false statement. How do you solve this? First of all, one by one we will check all the statements. That's the correct way to go. If you have another approach, you can go ahead. But what I am going to do is I am going to check one by one each statement. So this is the free body diagram. What is the load? 1500 Newton per meter. This distance is 1.5 meter. This is 0.5 meter. The points are L, M and N. This is L, this is M and this is N. So what are the reactions RL and RM? Let's find out. So I will just take the moment at L. Okay. If I take moment at L, then moment of RM will be equal to RM into 1.5. Moment of this UDL will be 1500 into 2 will be the load and distance will be 1. So what is RM? 2000, na? Rm is 2000 Newton or 2 kilonewton, and from summation of Fy equal to 0, RL plus Rm will be 1500 into 2. So RL will be equal to 1000 Newton. So the first statement is correct, I think. Na? The reaction force at L is 1 kilonewton and reaction force at M is 2 kilonewton. The first statement is true. No issue with that. Second statement, bending moment is 0 at L and N. Obviously, it will be 0 at L and N, and at a point in between L and N. I think the second statement is also correct. Third statement, bending moment is 0 at L and N only. Okay, so B and C both are contradicting statements, so maybe one of these statements is wrong because both are contradicting. So both statements cannot be wrong, right? Sorry, both statements cannot be true. So one of these statement is false. Shear force is 0 at L and N and at a point in between L and M. Yes, D is also correct in a way. Some of the people are saying D is wrong because shear force at L will be equal to RL. One of the shear force at L will be equal to 0. So D can be true. If you are saying that shear force at L will not be 0, it will be equal to RL. Beta, one of the values at L, the shear force will have two values at L. One of the values will be 0, na? So D is correct statement only. Okay. So one of B and C is wrong because both are contradicting. Okay. So what they are saying? Bending moment at L and N are 0 according to both. Okay. Bending moment in between L and M is 0 or not, that we need to check. So let's check. How we will check? Let's draw the bending moment diagram. Na? We will get to know. So RL is 1000 Newton. This is 2000 Newton. So let's draw the bending moment diagram. We will get a clear picture. So the bending moment at L will be 0. Okay. What will be the bending moment at M? So bending moment at M will be 1500 into 0.5 into 0.25, 187.5, and it has to be what? It has to be negative. Okay. So bending moment here will be minus 187.5. Bending moment here should be 0. Bending moment here should be 0. Right? So it will go like this. The bending moment diagram will be something like this, na? The bending moment diagram will be something like this. Somewhere here bending moment will be 0. Okay. You can find that point. Can you find this point? The bending moment here will be 0. Can you find this point? Yes, let's find this point. So bending moment at X is 0. Right? So bending moment due to this 1000 will be 1000x, and bending moment is due to this UDL will be 1500x square by 2. So this will be 1000 equal to 750x. So x will be 1000 by 750. How much are we getting? 1.33 meters. See? So bending moment between L and M will also be 0. Somewhere here 1.33 meter. Okay. This is the bending moment diagram. Okay. I assumed that bending moment somewhere here is 0, and then I calculated the distance. If this distance is more than 1.5 meter, means your assumption is wrong. But I am getting 1.33 meter, which is well within the range. So my assumption is correct. So which statement is false? C statement is false. Bending moment is only 0 at L and N. No. Bending moment will also be 0 between L and M. Right? See, lot of students are saying B is the false statement. B is the true statement. What you guys are doing? Just now I have proven that x equals to 1.33 meter, bending moment is 0, and then you are saying B is wrong, B is false. No, B is true, C is false. Okay, bending moment is not only 0 at L and N, it is also 0 between L and M. Okay, bending moment is 0 here, here and here at these 3 points. Okay, chalo. Let's move on to the next question, and this next question is another very interesting question. Okay, a simply supported beam of rectangular section is subjected to point load of 100 kilonewton. Width of the beam is constant and height varies linearly. Maximum bending stress at a section 0.2 meter from the left end is. Interesting question, right? See, this is a problem where the cross section is not uniform. Okay, it is a varying cross section, but here they are asking you to find the bending stress at a particular section. So it doesn't matter whether the section is varying or whether the section is constant, because the formula is same. Sigma will be 6m by bh square. Sigma maximum will be 6m by bh square. Okay, the only thing you need to calculate is m and h. Okay, the width is constant. Okay, but the height is varying, right? So you know the height here, you know the height here. You will need to find the height at this section, which is 0.2 meter from the left, and you will also need to calculate the bending moment at this section. So these two things you need to calculate. The formula will remain same, 6m by bh square. It doesn't matter whether it is constant beam, cross section beam, or varying cross section beam, doesn't matter. Sigma maximum will be 6m by bh square for rectangular cross section. Okay, so let's find out the bending moment at the section. So it's a simply supported beam which is subjected to point load at the center. Na? Point load is 100 kilonewton. So this is 100 kilonewton, means this will be 50 kilonewton, this will be 50 kilonewton. Now from here to here length is 0.6. We need to find bending moment at a section here. This distance is 0.2. Let me call this YY section. So bending moment at YY section will be equal to how much? 50 into 0.2 means 10 kilonewton. Here. So the bending moment at the section will be 10 kilonewton meter. Now we also need to find the height at this section, because we don't know this height. Na? We know this height, we know this height. So it's linearly varying. We can apply similar triangle. This is from left to center. This is point A, point C. Okay. This height is how much? 120. This height is how much? 300. We need to find this height, which is how much? Let's say this height is h. Okay. Now this distance is 0.2 meter and this complete distance is 0.6 meter. So what will be the value of H? See, if you draw a line from here, this will be H minus 120 and this will be 300 minus 120. Yes, if I draw a line, this will be H minus 120, this will be 300 minus 120, right? Let me draw that line for you. So I am saying this is H minus 120 and this is 300 minus 120, which is 180. So can I apply similar triangle between this? What I am saying? So sorry. This is H minus 120 and this is 300 minus 120. I'm so sorry for the mistake. So can I apply similar triangle between this and this? Yes. H minus 120 by 0.2 will be equal to 180 by 0.6. So H will be equal to how much? 60 plus 120, 180. H is equal to 180 mm. It's okay, Sanket, you can still join, you can still solve the problems. H is equal to 120 mm. Sorry, 180 mm. Now, sigma maximum will be how much for a rectangular cross section? Sigma maximum will be 6m by bh square. So, your bending moment is how much? 10 kilonewton meter, means 10 into 10 to the power 6. Your width is how much? Width is 20 mm. Width is 20 mm and height is 180 mm. So tell me, what is sigma maximum? .59 megapascal. Now, can I tell you one variation of this problem? See, this question is not very difficult, right? Because the challenge is only to calculate the bending moment and the height at this particular section. But what will be the challenging question if I ask you to calculate the maximum bending stress in this entire beam? Are you getting my point? If I ask you to calculate maximum bending stress in this beam, what will be the challenge? Understand. The challenge is to find a section where the bending stress will be maximum. See what is happening here. If you move from left to center, bending moment will increase, means your load will increase, but the height will also increase, means the area will also increase. So are you understanding what I am saying? Usually what happens, at the center bending moment is maximum, so we calculate the bending stress at the center because it is maximum at the center. But here at the center bending moment will be maximum, but bending stress will not be maximum, because at the center cross sectional area is maximum. So bending stress will not be maximum here. Bending stress will be maximum somewhere between A and C at some distance x. So you will have to find that x. In order to calculate maximum bending stress, you will have to find that x. So what you will do? You will find the equation of bending stress in terms of x. You will find the equation of bending moment in terms of x. Okay. You will find the equation of height in terms of x. Then you will put those equations here. So you will get bending stress in terms of x. Then you will differentiate that bending stress with respect to x. put it 0, you will get the value of x where bending stress is maximum. Okay, is this clear to everyone? But it will be very complicated because I think the equation of bending moment will not be very difficult. It will be 50x kilonewton meter, but the equation of h will become complicated. So when you will put the value of h in terms of x here, it will be very difficult to differentiate and find the value of x. Okay, is this clear? Chalo. Now solve this question. This is an interesting one. A horizontal bar fixed at one end has a length of 1 meter and cross-sectional area of 240 mm square. Its elastic modulus varies along its length, where x is the length coordinate along the axis of the bar. An axial tensile load of 10 kilonewton is applied at the free end. Axial displacement of the free end is. There was a question in GATE Mechanical long time ago. There was a question in GATE Mechanical which was very similar to this. Okay, I just changed the equation of E. So what you are going to do here? See, this is the bar. It is fixed at one end. Okay, and it is subjected to a tensile load of how much? 10 kilonewton at the free end, right? Now they are saying x is equal to 0 at the fixed end. So x is measured from here. Okay, in this equation x is measured from here. That is very important. You can't change that. Okay, so what we can do is we can consider a strip here. Okay, length of the strip is dx, let's say. This is x. So what will be this? What will be this remaining length? 2 minus x. Okay, x is in meters. Is x given in meters? Yes, x is in meters. Okay, and the length of this strip is very small, dx. Okay, now understand what will be the change in length of this very small strip. It will be P, means 10 kilonewton, into dx divided by A into E, right? Change in length of the strip will be P into dx divided by A to E. Now if you want to find the total change in length, you need to just integrate this from 0 to L. That's all you need to do. Okay, so here this doesn't matter whether this is 2 minus x or this is x in this particular problem. Okay, so what will be the limit? 0 to 2. I am putting everything in meter so that I don't have to change this equation. Okay, so 0 to 2, P is 10 kilonewton, so 10 into 10 to the power 3 Newton dx divided by area is 240 mm square. Let's convert it in meter square. So 240 into 10 to the power minus 6, right? And Young's modulus is 10 plus 20x gigapascal. Convert it in megapascal by multiplying 10 to the power 3. So from here you will get delta L in meters. How much is it? Be very careful with the units, okay? I am getting a huge value. Oh, I'm so sorry. This should be 10 to the power 9, na? Because I am putting everything in Pascal. I am getting 3.35 into 10 to the power minus 3 meters. So delta L will be 3.35 mm. Are you getting this? 3.35 mm. Very good, very good. 3.35 mm. Why are you guys getting 2.28? It should be 3.35, na? Must be making some mistake. 3.35 mm. Everyone is getting this answer? So this is the change in length. Okay. Done, everyone? I have converted everything in Newton and meter because in this equation x is in meters. So I converted everything in Newton and meter so that there is no confusion. Chalo. Moving on to the next question, and this one is an MSQ, means more than one possible answers. Okay. So I have taken care that you get questions from NATs, MCQs, MSQs, and also in the same ratio that you get in exam. See, 50-60% question in exam will be NATs, then almost 25-30% questions will be MCQs, 5 to 10% only will be MSQs. Okay, so I am maintaining that same ratio here also. A beam of uniform flexural rigidity EI is simply supported at the ends and loaded by couples M0 as shown in figure. Which one or more of the following statements is or are true for the beam? Maximum slope and maximum deflection. You need to find maximum slope and maximum deflection. Length is 1 meter of the bar. It is mentioned here the length is 2 meters. Na? Oh. So sorry. So sorry. Here I have made a mistake. I have mentioned two different lengths. I'm so sorry. My mistake. Okay. Here the length was mentioned 1 meter and here x was mentioned 2. So this was my mistake. I'm really sorry for that. I apologize. So 2.28 is also correct in that sense. Chalo. Let's solve this one. Now here we need to find the maximum slope and maximum deflection. It's a simply supported beam which is subjected to two couples. This is M0, L by 3, L by 3, L by 3. This is M0. The reactions will be 0, right? Because equal and opposite couples are acting. So net moment is 0. So the reactions will be 0, right? If you calculate the reaction, you will get the answer equal to 0 because these are equal and opposite couples. Okay. Now when they will bend, what will happen? From here to here and from here to here, elastic curve will be linear, right? Look at the bending moment diagram, you will understand how it is going to bend. So bending moment from here to here will be 0, then it will suddenly go up. This is going to be the bending moment diagram. Yes, 0, 0, M0, M0, 0, 0. Yes, is this clear to everyone? From here to here bending moment is 0. From here to here bending moment is 0 because there is no load. Between these 2 points bending moment will be constant m0, right? Now understand how this beam is going to bend. So when this beam will bend, from here to here elastic curve will be straight because bending moment is 0. From here to here also elastic curve will be straight because bending moment is 0. And between B and C the bending moment is what? Sagging, right? So there will be sagging here. So it is something like this. Can you imagine how it is bending? Is it bending like this? Is it bending like this? Yes. So here we need to find the maximum slope and maximum deflection. So how can we find it? Understand. See, if you calculate the slope at this point, you will get the slope at this point also, right? From here to here, it is a straight line. So whatever will be the slope at this point, what are these points? This is point A, this is point B, point C, this is point D, right? So if I calculate slope at B, slope at A will also be same, right? And there will be a center point, let me call it point O. Okay, let me call it point O. So at point O, the slope will be 0, right? At point O, the slope will be 0. So if I calculate the slope at point B, point A slope will be same. You can do this. Theta A minus theta O will be equal to area of bending moment diagram between AO divided by EI. Moore's first theorem. Theta O is 0, right? Because at center the stress will bending moment is 0. And what will be this area, beta? What will be this area? What will be this length? What will be this length? This will be L by 6. L by 3, this is L by 6. So m0 into L by 6 divided by EI. So theta A will be m0 L by 6 EI. Yes or no? m0 L by 6 EI. So this is the maximum slope. m0 L by 6 EI means A is correct answer. Now we need to find the maximum deflection. So how we will calculate the maximum deflection? Understand. Can I draw a tangent at point O? What is this? This is the tangent at point O, right? And can we find the distance of this tangent from point A? Can we find distance of this tangent from point A? Can we find this YA? This will be equal to YO, sorry, right? This will be equal to the maximum deflection, na? Y maximum. So I am taking tangent at point O and I am considering the distance from A. Okay, so this Y maximum is actually equal to TOA. Can I write it like this? TOA. So Y maximum will be equal to TOA, which will be equal to area between AO multiplied by XA bar divided by EI. So we will consider this same area m0 L by 6, but we will have to multiply the distance from this centroid. What is this distance, beta? What is this distance? This is XA bar. What is this distance? L by 3 plus L by 12. L by 3 plus L by 12. Divided by EI. So how much is your Y maximum? 1 by 3 plus 1 by 12 is 5 by 12. So 5 by 60, na? 5 m0 L square by 60 EI. No, not 5 by 60. 5 by 72. Oh, sorry. 5 by 72 m0 L square by EI. Yes? So D. So A and D are the correct answers. So I have used moment area method. Now see, you will not get these type of questions in mechanical. So those who are appearing for GATE mechanical, you will never get a question like this. This is very difficult. From deflection of beams, you will get very simple question. But for civil engineering students and for those who are appearing for GATE XC, you might get a question like this. Okay, for civil engineering and for XC, this is a relevant question. But for mechanical, GATE mechanical, you get simple questions from deflection of beams. You never get such difficult questions where you will have to use moment area method. Okay, is this clear to everyone? Chalo, let's move on to the next question. Cantilever beam shown in figure has an internal hinge at C. Bending moment at the fixed end A is. Now this is something which you see in every GATE exam. GATE mechanical, GATE civil, GATE XC. Similar question have been asked. Cantilever beam is given. There is an internal hinge at C. We need to find the bending moment at point A. How are we going to solve this? See, there will be a reaction here at the roller support, right? Let me call this reaction RE. So in order to find bending moment at A, we need RE. And how can we find this RE? C is an internal hinge and bending moment at the internal hinge is always 0. So from the right side, bending moment will be RE into 2 minus 8 into 1 equal to 0. So RE will be 4 kilonewton. So this is the reaction at E, 4 kilonewton. Once you get that, you can easily calculate bending moment at A, right? It will be equal to RE multiplied by this entire distance, 2 into 4 plus 2, 6, 4 into 6 minus 8 into 5 minus 12 into 2. So how much is the bending moment at A? This is 24, this is 24, cancelled. Minus 40 kilonewton meter means 40 kilonewton meter hogging moment, right? They are asking you the magnitude of bending moment only. So it is 40 kilonewton meter. Okay. Here everyone. Moving on to the next question, and this one is another very interesting question. And let me tell you again, you have got two questions in GATE mechanical similar based on similar concept. Two PYQs on GATE mechanical based on similar concept. A closed cylindrical pressure vessel of length 2 meter internal diameter 1 meter and thickness 10 mm, is rigidly supported at the top. It is filled with water up to a height of 1.5 meter from the bottom surface. Density of the water is 1000 kg per meter cube and acceleration due to gravity is 10 meter per second square. Neglecting weight of the vessel, axial stress in the cross section of the vessel at a height of 1 meter from the bottom surface is. The total height of the vessel is 2 meters. Water is filled up to 1.5 meter from bottom surface, and they are asking you to find the axial stress at a height of 1 meter from the bottom surface. How do you solve this question? I have explained how to solve this question in class, right? When the pressure vessel. Hello. We are back. Okay, so if you draw the free body diagram, you will get this diagram. At the bottom surface, weight of the water is acting. At the top surface, there is reaction at the fixed end. At every section, the internal force will be equal to the weight of water, right? So at every section, it doesn't matter where they are asking you to calculate longitudinal stress. At every section, longitudinal stress will be same. Even here, where there is no water, longitudinal stress will be same. So longitudinal stress sigma L at every section will be weight of water divided by area. Okay. Now what will be the weight of water? What will be the weight of water? Weight of water will be volume, weight per unit volume multiplied by volume, right? Weight of water will be weight per unit volume multiplied by volume. So weight per unit volume will be rho into G multiplied by volume A into L divided by L. So it will be rho into G into L, where L is the height of water, 1.5 meter. I should write it H. Just to understand, I should write it H. H is the height of water, not height of vessel. Okay, I am considering here the weight of the water, not the weight of the vessel. So height of the water you have to consider. So sigma L will be equal to rho G H. So rho is 1000, G is 10 and H is equal to how much? Wait a minute. Here area will not be cancelled, na? So sorry. This is not the area of the vessel, na? Sorry, this is the area of the vessel. This W by A, let me write it like this, pi dt. Okay. So here rho G H divided by pi dt. I'm so sorry, it will not be cancelled. Chalo. So put all the values here. So this rho is how much? 1000. G is 10. Area will be equal to how much? Area of water will be pi by 4 into d square, na? What is the diameter? Internal diameter 1 meter, sorry. And height of water is 1.5. Now this is in Pascal. Okay, this is in Pascal, means this is in SI unit. So here you are getting it in everything in unit Newton, na? So you don't have to convert it. Divided by pi into the diameter. Now here diameter will be 1000 mm, and what is the thickness? Thickness is 10 mm. So sigma L will be equal to how much? Just understand that this is the area of water and this is the area of the vessel. When you will cut it, you will get a hollow circular section. So this is the area of the vessel, but this is the area of the water. So water is filled in this much part. So pi by 4 d square. Okay. Chalo, what you are getting? Pi and pi will be cancelled. 0.375 megapascal. Are you getting this much? 0.375 megapascal. Yes. 0.375 megapascal. Is this clear to everyone? Is this clear to everyone? So total weight of water divided by area of the vessel. In total weight of water, this will be weight per unit volume multiplied by volume of water divided by area of vessel. Do not confuse this as area of vessel and height of vessel. Area of water, height of water. Okay. Chalo. Now solve this. This is related to impact loading. So you can see that we have questions from different chapters and different topics, and we have questions you have never seen before. So I hope you guys appreciate the effort that I have made in picking these questions, right? The 800 Newton block hits the simply supported beam at its mid span after a drop of 10 mm as shown in figure. Young's modulus is 200 GPa. Cross section of the beam is rectangular. The block and the beam stay in contact after the collision. Maximum deflection of the beam due to the impact is. So here you need to find the maximum deflection of this beam when the weight is dropped at the center of the beam. So it's a simply supported beam, right? First we will calculate the Y static. Okay. Y static means if this same load is applied gradually, then what will be the deflection? So this 800 Newton load is, let's say, applied gradually. Okay, so what will be Y static at the center? So it will be WL³ by 48 EI. Yes or no? WL³ by 48 EI. Right? Ys will be WL³ by 48 EI. So here what will be W? 800 Newton, length 1.2 meter. Young's modulus is 200 GPa. For calculating I, the cross section is given 60 by 30. So calculate the Y static here. So 800 into 1200 mm cube divided by 48 into 200 into 10 to the power 3 multiplied by I, which will be what? BH³ by 12, right? So B is 60, H is 30, so BH³ by 12. So from here you are going to get Y static, means the deflection at center if the load was applied gradually. So if the load was applied gradually, deflection would have been 16 by 15 mm. Are you getting this? 16 by 15 mm. Yes. So if the load is now dropped from some height, what will be the deflection? Y due to impact load will be Y static into impact factor, na? And what is impact factor? Impact factor is 1 plus root over 1 plus 𝐂𝐻 upon Y static, right? So Y static is 16 by 15 multiplied by 1 plus root over 1 plus 2 into, what is the height? Height of drop is 10 mm. So it is dropped from only 10 mm height. Y static 16 by 15. So from here you will get the deflection at center due to impact load. So how much is it? $5.807 or 5.81 mm. Yes, very good, yeah, Rohan, very good. 5.81 mm. So this will be the deflection due to the drop, due to the impact. If the load was gradually applied, deflection would have been 1 point something mm, but now due to the impact, it is increased to 5.81 mm. Okay, so you need to just multiply it with impact factor. Okay, clear? Very good. Moving on to the next question, and we have a similar question like this in GATE Mechanical 2 years ago, I think. Sir, I saw a question in 1 GB that was a question with unsymmetric, simply supported and impact loading deflection was asked. It was a very lengthy question. See, if you are solving 10 GBGs, if you are solving 10 mock tests, you will find 2 or 3 such type of questions. Okay, if you see previous year questions in GATE also, in last 10-15 years, you will find 2-3 difficult and lengthy questions. But those questions are rare. So don't worry about such type of questions. Okay. Rohan is talking about a very complicated question that I gave in mock test. I admit that sometimes in mock test, I give these very difficult and lengthy questions intentionally to check how many of you can solve that question. Okay, who is that brilliant student who can solve that question in time? Okay, it is just to check that, and you get similar questions in GATE also, but in 10-15 years you will see only 2-3 such type of questions. Okay, beta, you don't need to worry about deviator component in strength of materials. Okay, don't worry. A bar ACB having two different solid circular cross sections is held between rigid supports as shown in figure. Cross sectional area of the left and right hand parts are 2000 mm square and 4000 mm square. Corresponding lengths are 225 and 300. Modulus of elasticity is 6 gigapascal and coefficient of thermal expansion is given. Bar is subjected to uniform temperature increase of 30 degrees centigrade. Displacement of point C is. Now displacement of point C, in order to calculate displacement of point C, you need to find the force developed here and here, okay, or here. So in order to calculate the force, what you will do? You will apply compatibility equation delta L equal to 0, right? Now delta L equal to 0 means change in length due to temperature plus change in length due to forces will be 0. Now what will be the change in length due to temperature? L alpha delta T, right? Now AC and BC both have same alpha and delta T. Only the area is different. So when we are calculating change in length due to temperature, we don't need to consider AC and BC separately. We can consider them as a single body. So the length will be 300 plus 225, 525. Okay. I can just write it like this first. L alpha delta T of AB minus. Now here, when we are calculating change in length due to force, both will be subjected to compressive force P, right? So this will be minus PL by AE of AC plus PL by AE of BC equal to 0. Okay. So here L of entire bar will be 525. Alpha is 100 into 10 to the power minus 6 and delta T is 30 degrees centigrade. Okay. This will go towards the right side. P is common, so it will go out. Length of AC is 225. Area is 2000 mm square. And Young's modulus is 6 gigapascal. Then 300 divided by 4000 mm square, Young's modulus 6 gigapascal. Now in this entire equation, P is unknown, so you will get the value of P. (525) into 100 into 10 to the power minus 6 into 30 divided by this 50400 Newton. So this is the force developed in the bar. Okay. Now 2 alpha delta T hoga. So now 50400 Newton. This is the force developed in this entire bar. Okay. Now what we need to do? We need to calculate the deflection of C, right? So in order to find deflection of C, you can either calculate change in length of AC or you can calculate change in length of BC. Both will be equal and opposite. Okay, if one is positive, another one will be negative. So either calculate change in length of AC or calculate change in length of BC. So horizontal deflection of C will be change in length of AC. Now change in length of AC means L alpha delta T of AC minus PL by AE of AC. Okay. So what is the length of AC? 225. So 225 into 100 into 10 to the power minus 6 into 30 minus P is 50400 multiplied by length 225 divided by area 2000, Young's modulus 6 into 10 to the power 3. So horizontal deflection of C, how much are you getting? Minus 0.27 mm means AC is getting compressed. AC is getting compressed by 0.27 mm. BC will expand by 0.27 mm. Okay. So the horizontal deflection of C will be 0.27 mm. Yes. Very good. 0.27 mm. Okay. If you calculate change in length of BC, you will get plus 0.27. Okay. Because AC is getting compressed by 0.27, BC is getting expanded by 0.27 mm. Okay. Chalo. Moving on to the next question and another MSQ. solve this one. The state of stress at a point subjected to biaxial stresses is shown in figure. Which one or more of the following statement is or are correct? Normal stress on plane AB is 85 megapascal or 5 megapascal. Shear stress is 40 or 20. So you need to calculate the sigma and tau on plane AB. That's it. Sigma and tau on plane AB. So sigma at angle theta is equal to what? Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta, right? Here theta is equal to how much? Clockwise angle, so minus 45 degree. Okay, so sigma AB will be equal to sigma x is 80, sigma y is 0, tau xy is 45. So 80 by 2 plus 80 by 2 cos minus 90 degree plus 45 sin minus 90 degree. Okay, so what is cos 90? It's 0, right? And sin minus 90 is minus 1. So 40 minus 45 minus 5 megapascal. Yes. So B is the correct answer. Normal stress at point on plane AB will be 5 megapascal. Now shear stress tau at angle theta will be minus of sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. So tau on plane AB will be minus of 80 by 2 sin minus 90 plus 45 cos minus 90, the cos minus 90 is 0, this will be 40 megapascal. Yes. So shear stress on plane AB will be 40 megapascal. So B and C are the correct answers. And with this, we conclude this session of Super 20. I hope you liked the questions. I tried to include as many topics as possible, and I tried to include all types of questions, MCQs, MSQs, NATs. They were easy questions, they were moderate questions, they were difficult level questions also, right? But this is not the only practice session you get to see today. This is our Telegram group. You will get the notes here. So join this Telegram group. Okay, scan this QR code or just search this name in Telegram. And we have Maha Abhyas also today at 7 PM. But this will be in our GATE mechanical channel. Okay, GATE Wallah 𝐂𝐚𝐿𝐻, that mechanical civil channel. Na? So there we will have another Maha Abhyas of strength of materials at 7 PM. And I will bring you another super 30 questions at 7 PM. Okay, so have your dinner early or very late, because it will take at least 3 to 4 hours to cover all 30 questions. They will be different from these 20 questions. I will include different variety of questions. So you will get total of 50 questions today of strength of materials. Okay, so this is the Maha revision schedule. Tomorrow you have Maha revision of manufacturing process for mechanical by Swadesh sir. This is Maha Abhyas schedule. This is Super 20 schedule for mechanical engineering. For civil engineering, tomorrow at 4:30 PM, you have Maha revision of Geotech by Badal sir. Okay, then this is Maha Abhyas and Super 20. Okay, again join this Telegram group, and thank you so much. I will see you at 7 PM. It is 4:11 right now. I will see you at 7 PM sharp to solve more questions of strength of materials at GATE Wallah 𝐂𝐚𝐿𝐻 channel. Till then, bye bye, take care, Jai Hind.